The Hovercraft is one of the most versatile vehicles ever invented. Devised and patented in 1952 by British inventor Christopher Cockerell, it can accomplish anything a fast boat can. But because it's amphibious, it can also tackle land, mud, ice, swamp, rocks, and rapids. This incredible versatility makes it ideally suited to everything from sightseeing to firefighting. Creating a hovercraft that's fast, strong, and reliable enough to work in the most hostile environments on Earth means pushing the design and engineering to the limits. So, how do they do it? It's a hazy Tuesday morning in Southampton on the south coast of England, and pilot Rob Trussler is about to take a new generation of advanced military hovercraft out for its final test run. Designed and built for the Swedish Navy, this is the 8100 TD. Capable of carrying a payload of more than 12 tons and almost 100 passengers, it's over 65 feet long and weighs nearly 40 tons fully loaded. Despite its weight, it can glide more than 3 feet above the ground and reach a top speed of 50 knots. Today, Rob will push every aspect of the machinery to the max to ensure everything is working to its full potential.
The last trial that we're actually doing with the craft, and it's a 4-hour endurance trial where we have to operate the craft at a full power setting because we're making sure that the product we built is going to do what we say it will do.
The 8100 TD is the latest and most sophisticated model created to date by engineers at Griffin Hovercraft. Like any seafaring vessel, the design of the 8100 TD begins by creating the hull. Typically, a ship's hull is fabricated from steel, but steel would be far too heavy for a hovercraft. So instead, they turned to marine-grade aluminum, as Chief Designer John Barker explains.
We use aluminium, firstly because it's very light. It's also resistant to damage. This will bend rather than crack, as a composite material would do, and it's easily repairable. You can just rivet a patch on with some glue.
Unlike a ship, the hull of a hovercraft needs to work on land as well as sea, which means it must be strong enough to withstand a few knocks should it collide with any obstacles. To prevent the entire craft from sinking if the hull is punctured, it's made from multiple self-contained chambers. Thanks to this compartmentalized design, it's possible for up to half of the hull to be damaged before it would sink. But what makes a hovercraft special is its ability to hover. So once the hull has been coated with high-spec aircraft paint for protection, it's fitted with a pair of Iveco Vector 20 engines, each one generating 1,000 brake horsepower. These not only provide forward power via two 10-foot-high propellers, but also drive 4 3-foot diameter fans at the center of the craft. These fans force huge volumes of air under the hull, which is then trapped by a reinforced rubber skirt. The skirt is made from 2 parts. The upper part is called the loop and is one piece of rubber which runs around the base. Under that, it's divided into over 100 independent sections called pleats, or fingers. These pleats make contact with the ground and are designed to flex with the airflow. The more they flex, the faster the craft is able to go. Viewed from underneath the skirt, you can see how the craft is able to hover equally high over both land and water. However, as the craft moves, the pleats are subjected to enormous wear and tear. By making them removable, Should any section become damaged, then only that one panel needs to be replaced. You might expect a massive craft like the 8100 TD to generate an enormous amount of air pressure as it hovers. But in fact, the pressure inside the skirt is so low, it's possible to work inside as the craft runs. Thanks to this low pressure, Griffin boasts that the craft is immune to mines. To put their claims to the test, we decided to borrow pilot Rob from his testing duties to undertake a little challenge of our own. Over 20 tons of hovercraft versus 2 ounces of raw egg. Strictly speaking, this isn't one of the tests required by the Swedish military. But nonetheless, Rob predicts it'll be a cakewalk. So, will Rob wind up with egg on his face and all over the beach as our tester cracks under pressure? Or will his skirted hover monster sail over our devilish culinary challenge? The outcome? Not a crack.
We didn't break the egg. 27 tons and we didn't break the egg.
Having completed our challenge, the craft sails through its final sea trial with Rob pushing the vehicle all the way to its maximum speed. Combining the ability to fly like a plane and float like a boat, the hovercraft is the most extraordinary form of transportation ever invented. And with the success of this latest model, its designers are literally riding on air.